This is a special video for those of you who are struggling with proofs and who really want some extra help preparing for the proof question on the test. So first I want to review some basics. How to prove trigonometric identities. There are many ways to prove an identity. Here are some guidelines. Now, the number one thing I want you to pay attention to is that your identity that you are trying to prove is not an equation to solve, but two distinct expressions that must be shown to be equivalent. This is extremely important, and one of the biggest mistakes I've seen students making is that they keep rewriting the identity as though it's an equation, and then they try to manipulate that seeming equation using the principles of equation solving. That's not what we're doing here. So here are some ways that you can start to tackle proofs. You can work on the side that is more complicated and try to simplify it. This is usually my go-to. Any side that looks a little bit more complicated than the other is the one that I'm going to go to straight away. If you don't know what to do, if there's nothing clear, one technique that sometimes works is to just replace all of the trig functions with variants of sine and cosine. Any sort of substitution that you can make that's legal, that involves sine and cosine, do it. That doesn't always work. Sometimes instead you want to focus on other operations that need to be factored. Or is there anything that could be expanded? Distributive property, can I add or subtract or multiply any fractions together? Anything that's algebraic can help simplify an expression further. And this is also where I actually see a lot of students having difficulty. It's not so much that the proofs themselves are as problematic as the algebra involved. And it could be the anxiety about the proofs that's causing this to happen, but a lot of students are making a lot of algebra mistakes, and that's why their proofs are incorrect. Use the various trig identities. Have that back of the book open so that you can see those fundamental identities. Here's another technique that works really well. Work from both sides. Keep an eye on the other side as you're working towards it so that you know the direction you're heading. And then also consider the trigonometric conjugate. That would be, so if you have cosine theta plus 1, the conjugate would be cosine theta minus 1. Anything that's going to create a difference of squares is usually good because you can create a substitution using one of the fundamental identities. Alright, so that's the basic overview, and now we're going to actually dive into some of the proofs you might see on the test. Okay, so here's our first problem. We are going to be just focusing on this upper part of the screen. You can ignore this lower part of the screen. This is going to be a basic trig identity that you need to prove, and I'm going to put it up on the board and show it to you. If you're having trouble with proofs, the first piece of advice I would give you is to draw a line under the equal sign. Not only will this keep you from rewriting the equal sign, because this is not an equation to solve. You must somehow manipulate the left expression and the right expression, or one or the other, so that they look like each other. If you draw this line, it will guard you against using the equal sign as though we have an equation here. The second reason for this line is that this line is going to help you keep your work organized so I can read it, okay? So very important piece of advice. Do this so that I can follow your work and do it well. Now, do you remember the piece of advice that says keep your eye on the other side of the equation? When you're thinking about which side is more complicated, well, I would say the left-hand side is more complicated because cotangent is 1 over tangent. And yes, it's true that tangent is 1 over cotangent, but typically we think of cotangent being the reciprocal. And then second, I would say since I see that I need to change cotangent into tangent, this is look at the other side, keep your eye on the ball, instead of doing a substitution for cotangent that is cosine over sine, I'm going to be motivated to do a substitution for cotangent so that it's just 1 over tangent because I see tangent on the other side. So now I replace each occurrence of cotangent with 1 over tangent. So this then is a complex fraction. And when we clear the complex fraction, you need to show your work. So what we want to do is multiply by the LCD of all of the little denominators, and there is only one little denominator, and that's tangent x. So I'm multiplying the entire left-hand side by a form of 1, because remember that this is an expression to be manipulated, which means you can only ever multiply an expression by 1. So this right here is a form of 1. Now I'm going to use the distributive property. Tangent x times tangent x is going to give me now tan x over tan x, and then I have minus 1 times tan x. For the denominator, tan x over tan x plus 1 times tan x. Keep in mind you only have one proof on the test. If you err on the side of anything, err on the side of showing more work, not less work. Tan x over tan x simplifies to 1. 1 times tan x is tan x. The denominator becomes 1 plus tan x, and now the left-hand side is equal to the right-hand side. Okay, let's look at another one. So for our next one, we have 1 over 1 minus sine x minus 1 over 1 plus sine x. We have to somehow get this left-hand side to equal the right-hand side. So I'll put this up on the board. So on your paper, also copy the original identity to be proved, then draw a line under the equal sign. Now, which side looks more complicated? The left-hand side. We have fractions and we have a subtraction problem. Now, this is great because when we see fractions that need to be multiplied or added or subtracted, then we want to go ahead and do that. And to do so, we need to use a common denominator. So we need to show multiplying the numerator and denominator of each of these fractions by something that will result in a common denominator. So for this first fraction, I'm going to show multiplying by 1 plus sine x over 1 plus sine x. Show as much work as possible. It's a proof. A proof should not put any burden on the reader. The reader must be entirely led through every part of the process without any jumps whatsoever. Okay, now I'm going to combine. I have this first and second fraction. Now each are 1 plus sine x, 1 minus sine x. For the numerator here I have 1 plus sine x, and for this numerator right here 1 minus sine x. So now I'm going to combine into one fraction. So I have 1 plus sine x minus 1 minus sine x, and now I'm going to use the distributive property. Oops. Okay, and now I'm going to combine anything in the numerator that can be combined. Now I've run out of space here, so what I'm going to do is I'm going to move everything up. So I'm going to erase some of these higher lines and move this up so you can see me continue, okay? So make sure you keep a note of everything I've done so far. Of course, you can rewind the video or go back in the video. So let me move this up. I have 2 sine of x. So now what I want to do is I want to multiply the denominator. Now technically I could have done that in the previous step because as I was simplifying the numerator, I could also simplify the denominator at the same time. So it would have been permissible to combine simplifying the numerator and simplifying the denominator into one step. Make sure that the squared happens before the x. Otherwise, it will become ambiguous as to whether the square applies to the x variable or the entire trigonometric function. Next, we replace 1 minus sine squared x using one of the variants of the Pythagorean identity. So note that cosine squared x plus sine squared x is equal to 1. Therefore, cosine squared x is equal to 1 minus sine squared x. So you can do this sort of note yourself as part of the proof, but I also just accept that you can replace cosine squared x at any time with 1 minus sine squared x or vice versa. Okay, so meanwhile, you may notice that on the right-hand side, I have a tangent and a secant, and so I'm keeping my eye on the ball. How do I rewrite this as that? Now, I can either split this up, or I can just work on the right-hand side. So it's up to you. Let me show both ways. So if I were to rewrite on the right-hand side, I could rewrite tangent and secant. I could rewrite tangent as a sine over cosine, and write secant as 1 over cosine x. And then when you combine these into one fraction, you get 2 sine x over cosine squared x. And notice now the left-hand side is equal to the right-hand side, so you can stop. Now alternatively, instead of manipulating the right-hand side, you could have continued with the left-hand side. So if you did that, you would want to split this up into 2 times sine x over cosine x times 1 over cosine x. So you would actually want to show splitting this up further before you then rewrite this as 2 tan x secant x. Okay, so either way would have been fine. Okay, let's do another problem. New version. Okay, this one's too similar to what we just did, so let me get another version again. Okay, so this one is different from what we have done. Let me get this one up on the board. First, I want to draw a line. And this is one of those problems where the recommendation to change everything into some sort of version of sine and cosine is the best advice. So let's rewrite tangent as sine x over cosine x. Rewrite cotangent as cosine over sine. I can work the left and the right at the same time. It's like 2 separate individual expressions that I'm manipulating. The red line keeps me from thinking that this is an equation. Secant is 1 over cosine, and cosecant is 1 over sine. Okay, so now what I want to do is I want to give these a common denominator, because when I'm adding or subtracting fractions, that's usually when I get the most possibility for manipulation. So I'm going to rewrite sine x and cosine x with a product entered into here of sine x over sine x for the first fraction and cosine x over cosine x for the second fraction, and you can see then I'll get a common denominator. So now I have sine squared x over sine x cosine x plus cosine squared x over cosine x sine x. But cosine x sine x is the same denominator, so we can combine this into one. Sine squared x plus cosine squared x over sine x cosine x, and then you can replace sine squared x plus cosine x with 1. And so I can take this a step further over here on the right and combine these as a product into 1. And if you want, then you can also now rewrite this as sine x cos x with 1. As I was saying, err on the side of showing more, not less when it comes to proofs. So for our next proof, we'll do this one right here. Sine x plus cos x times tan x plus cotangent x equal to secant x plus cosecant x. So this is a tricky proof, so the good thing is you get to see it now. There's a lot of rabbit holes you could go down. I'm going to try something here. Let's see. I'm going to leave sine x and cosine x as is. I'm going to try the trick of rewriting just in terms of sine and cosine, which would apply just to these right here. Okay, so if I were to combine these together, I would need to have a common denominator. So what I'm going to do is I'm going to show changing these fractions only. Let these guys just hang around for the ride. I have my sine x over cos x and cos x over sine x. And now let me just multiply this by a sine x over sine x, and this one by a cos x over cos x. And what will that do? Let me just keep this on the outside. So now I have a sine squared x over sine x cos x and a cosine squared x over sine x cos x. And I saw that in my mind's eye as I was thinking about tangent and cotangent and how I could combine them. This is a really good thing, having a sine squared plus a cosine squared, right? So let's keep going here. Sine x plus cosine x. Now I'm going to combine this into one fraction. So I have a sine squared x plus cosine squared x over sine x cosine x. Next line down. Sine x plus cosine x. Now my numerator gets replaced by 1. And my denominator is still sine x cos x. Now I need more space, so I'm going to erase these right here. And then move this up. so I just moved that up here. Now I'm going to use the distributive property and distribute this to each term, and I end up with a sine x plus cos x that each get divided now by sine x cos x, and now the cosines here cancel, the sines here cancel. This is good. 1 over cosine x plus 1 over sine x, and what do we have over here? 1 over cosine x plus 1 over sine x, and we're done. So that's very good. Now it's really luck of the draw as to whether you get a hard proof or an easy proof, and I want to show you an easy one now. Tangent squared x plus 1 is equal to secant squared x. This is actually one of the fundamental identities, so it would be circular reasoning for me to use this very identity to prove this identity. So instead what I'm going to do is I'm going to convert tangent squared and secant squared to other things. Let me show you. Okay, so first draw a line. Secant squared, you're going to rewrite this as 1 over cosine squared. Tangent squared, you're going to rewrite as sine squared over cosine squared. Okay, so then in the next line, I'm going to show getting a common denominator. I'm going to multiply 1 now by cosine squared over cosine squared. And then that's going to give me sine squared x plus cosine squared x all over cosine squared x, which now I can rewrite as 1 over cosine squared x, and the left-hand side matches the right-hand side. So this was an easy proof. So you don't know if you're going to have an easy proof or a hard proof on the test, and since that's kind of luck of the draw, that's why the test only has 8% of the test devoted to proofs. So you could get an easy one or you could get a hard one. So the best way to prepare is to retake question number 4 as many times as possible. You get 100 different variations, and so you can keep pulling up the same kind of proofs again and again. There are a total of 16 different identities to prove. So if you can find all 16 of them and prove all of them in advance, then you will already be prepared for whichever one you get on the test. Okay, if you have any questions, just email me.